What if I told you the grand search for a theory of everything, that single equation that's supposed to describe all of reality, has been stuck for 100 years because of a typo? Seriously. Not some big mathematical blunder, but a simple mistake in how we name something. Today we're diving into a really radical framework called TMOA that makes that exact claim. It says we can unify all of science from top to bottom just by correcting one word choice made a century ago. So, let's see how one little typo could literally change everything.
Okay, so first, let's set the stage. The central problem in modern physics is pretty famous. You've probably heard about it. Our two best theories for describing the universe just don't talk to each other. On one hand, you've got general relativity, Einstein's incredible theory of the super big stuff, planets, stars, galaxies. And on the other, you've got quantum mechanics, our ridiculously successful theory of the super tiny stuff, atoms and particles. For a century now, they have refused to play nice. It's basically the biggest, most obvious crack in our entire understanding of reality.
So where does this TMOA framework say the problem is? Right here. It suggests that this whole split has nothing to do with flawed physics or bad equations. In fact, it argues Einstein's math was absolutely perfect. The entire conflict, it says, comes from a conceptual mistake, a semantic error, a simple mix-up in how we describe what those beautiful equations actually mean.
And this slide right here gets to the heart of it all. See, when Einstein was describing gravity, he basically had two ways to say the same thing. The one he chose, the one we all learn, is that mass curves the geometry of space-time. But TMOA argues he could have just as easily said that mass increases the local density of a medium. Think about how light bends when it goes into a glass of water. It's just following a change in density. Now, here's the key. Both of those descriptions predict the exact same thing in experiments. But that second option, seeing gravity as a property of a medium, is what TMOA claims unlocks, well, everything.
And this is the giant leap it takes. If gravity is just a density change in a medium, then maybe everything can be described in that same language. The TMOA framework lays it out like this. Everything in the universe, we're talking physics, chemistry, biology, even something like music, is all just the same single wave moving through the same single medium. The only difference is the scale we're looking at it from.
Okay, that's a huge claim, right? So how on earth could that actually work? Well, let's take a quick tour through the sciences, and we'll start with the theory that kicked this whole thing off, general relativity.
So in the old view, we have this kind of mysterious idea of space-time curvature, this notion that gravity literally warps the fabric of geometry. TMOA just sweeps that aside and says, nope, it's just a medium density gradient. And that little change in thinking is huge. An orbiting planet isn't following some abstract curved geometry through empty space. It's a wave, and it's just following the path of least resistance through a denser part of its medium. Suddenly, that whole mystery of action at a distance just vanishes. The medium itself is what's carrying the effect.
All right, now for the big one. Let's cross that great divide into the famously weird world of quantum mechanics and see how this framework holds up. The classic quantum head-scratcher, the collapse of the wave function. Well, in TMOA's world, there is no collapse. It doesn't happen. The quantum wave is a real physical thing. What we call a collapse is just what happens when our big, clumsy, macroscopic instruments try to measure a really fine-grained wave. We lose information in the process. Think of it like trying to take a photo of a super detailed painting with an old flip phone camera. The painting didn't collapse, you just took a low-res picture. The weirdness isn't in reality itself, it's in our act of observing it.
Let's keep this tour going. What about the particle zoo? The dozens and dozens of fundamental particles that supposedly make up our entire universe?
So according to this framework, you can just forget about particles being tiny little billiard balls. They're stable, standing wave nodes. A better way to think about them is like persistent, stable whirlpools or interference patterns in that one underlying wave. So the particle zoo isn't a collection of a bunch of different things. It's more like a catalog of all the different stable shapes that a single wave can form.
And all of this, it all builds to this. This table is where all comes together. I mean, just look at it. General relativity, biology, even music theory. They're all described by the exact same columns. You have a medium with certain properties and a wave behaving inside it. The claim here is just staggering. These aren't different subjects. They're the same subject, just operating at different scales with different properties in the medium.
But here's the twist. This is where the whole TMOA project gets really interesting. The ultimate goal isn't to go and revolutionize research labs with a bunch of new equations. No, The goal is to completely revolutionize the classroom with a new way of teaching science. So instead of teaching physics over here and chemistry over there and biology way over there as all these separate things, a student would learn this simple, unified story from day one. Step 1, there is one wave. Step 2, it propagates through a medium. Step 3, the medium's properties can change. Step 4, literally everything else follows from that. It's that simple.
And what's the payoff? Well, as this quote from the source material puts it, some of the biggest problems in physics just dissolve. The student who learns this way never asks, how do we reconcile quantum mechanics and gravity? The question does not arise. They were always the same wave. Wow, just think about that. The whole problem just vanishes before it even has a chance to form.
And that leads to this powerful concluding line from the manifesto, which really captures the passionate, beating heart of this whole idea. There is one wave. It has always been one wave. Teach it as one wave from the first day. It's basically a call to action to end what it sees as 100 years of fragmented science education, all because of one little conceptual slip-up.
So we're left with a final, really provocative thought. I mean, it's a wild, audacious idea, for sure. But it really forces you to ask the question, what if the ultimate key to unifying our understanding of the universe isn't some new particle we have to find, or some more complicated equation we have to solve, but just a new story? What if the biggest barrier we face is the one we built ourselves, right there on the first pages of our textbooks?